The future of identity management using blockchain technology. The future of identity management is being reshaped by blockchain technology, offering a transformative approach to how individuals and organizations manage, verify, and secure personal identities. Traditional identity management systems are often centralized, fragmented, and vulnerable to data breaches, identity theft, and inefficiencies. Blockchain, with its decentralized, immutable, and transparent nature, provides a robust foundation for creating more secure, efficient, and user-centric identity management solutions. By leveraging blockchain technology, the future of identity management promises to enhance privacy, reduce fraud, streamline verification processes, and empower individuals with greater control over their personal data. One of the most significant advantages of blockchain-based identity management is enhanced security and privacy. Traditional identity systems store personal information in centralized databases, which are attractive targets for hackers. High-profile data breaches have exposed millions of individuals to identity theft and fraud, highlighting the vulnerabilities of centralized systems. Blockchain, on the other hand, decentralizes data storage, distributing it across a network of nodes. This makes it significantly more difficult for attackers to compromise the system. Additionally, blockchain's cryptographic techniques ensure that data is securely encrypted and can only be accessed by authorized parties. For example, a blockchain-based identity system could use public-private key cryptography to allow individuals to prove their identity without revealing sensitive information. This approach, known as self-sovereign identity (SSI), empowers individuals to control who has access to their data and for what purpose, enhancing privacy and reducing the risk of misuse. Self-sovereign identity (SSI) is a cornerstone of blockchain-based identity management. SSI enables individuals to own and manage their digital identities without relying on centralized authorities. In an SSI system, personal data is stored in a digital wallet on the user's device, and identity verification is performed through decentralized identifiers, DIDs, and verifiable credentials. DIDs are unique, cryptographically secure identifiers that are registered on a blockchain, while verifiable credentials are digital attestations issued by trusted entities, such as governments or educational institutions. When a user needs to prove their identity, they can present a verifiable credential to a verifier, who can check its authenticity on the blockchain. This process eliminates the need for intermediaries, reduces the risk of data breaches, and gives individuals full control over their personal information. For example, a user could prove their age to a retailer without revealing their full date of birth or other sensitive details. Blockchain-based identity management also has the potential to streamline and simplify identity verification processes. In today's world, individuals often need to repeatedly provide the same information to different organizations, leading to inefficiencies and frustration. For instance, opening a bank account, applying for a loan, or signing up for a new service typically requires submitting identity documents, which are then manually verified by the organization. Blockchain can eliminate this redundancy by enabling reusable digital identities. Once an individual's identity is verified and recorded on the blockchain, they can share it with multiple organizations without needing to go through the verification process each time. This not only saves time and effort but also reduces the administrative burden on organizations. For example, a blockchain-based identity system could allow a user to verify their identity once with a government agency, and then use that verification to access services from multiple private and public sector entities. The use of blockchain in identity management also has significant implications for reducing fraud and enhancing trust. Identity fraud is a growing problem, costing individuals and organizations billions of dollars annually. Traditional identity systems are often susceptible to forgery and impersonation, as physical documents can be easily falsified. Blockchain's immutability ensures that once an identity record is created, it cannot be altered or tampered with. This makes it much more difficult for fraudsters to create fake identities or alter existing ones. Additionally, the transparency of blockchain allows for real-time verification of identity claims, reducing the risk of fraudulent activities. For example, a blockchain-based system could be used to verify the authenticity of academic credentials, ensuring that job applicants cannot falsify their qualifications. Similarly, it could be used to verify the identity of customers in financial transactions, reducing the risk of money laundering and other illicit activities. Another promising application of blockchain in identity management is in the realm of digital identity for the unbanked and underbanked populations. According to the World Bank, approximately 1.4 billion adults worldwide lack access to formal financial services, often due to the absence of verifiable identity documents. Blockchain-based identity systems can provide a solution by enabling individuals to create and manage digital identities without relying on traditional documentation. For example, a blockchain-based identity system could allow individuals to use biometric data, such as fingerprints or facial recognition, to create a digital identity that can be verified by trusted entities. This would enable unbanked individuals to access financial services, participate in the digital economy, and improve their economic prospects. Organizations like the ID 2020 Alliance are already working on blockchain-based digital identity solutions to address this challenge. The future of identity management using blockchain technology also extends to the Internet of Things, IoT. As the number of connected devices continues to grow, managing their identities and ensuring secure communication between them becomes increasingly complex. Blockchain can provide a decentralized and secure framework for managing IoT device identities, enabling secure authentication and data exchange. For example, a blockchain-based identity system could assign a unique digital identity to each IoT device, allowing it to securely communicate with other devices and systems. This would enhance the security and interoperability of IoT networks, enabling new applications in areas such as smart cities, healthcare, and supply chain management. Despite its potential, the adoption of blockchain-based identity management faces several challenges. One of the main issues is scalability. Blockchain networks, particularly public ones, can struggle to handle large volumes of transactions, which could be a bottleneck for identity management systems that need to process millions of verifications simultaneously. To address this, developers are exploring solutions such as Layer 2 protocols, sidechains, and hybrid blockchain models that combine the benefits of public and private blockchains. Another challenge is interoperability. For blockchain-based identity systems to be widely adopted, they need to be compatible with existing identity frameworks and standards. Efforts are underway to develop interoperable standards, such as the Decentralized Identity Foundation, DIF, and the World Wide Web Consortium, W3C, to ensure that different blockchain-based identity systems can work together seamlessly. Regulatory and legal considerations also play a crucial role in the future of blockchain-based identity management. Governments and regulatory bodies need to establish clear frameworks that support the use of blockchain for identity management, while ensuring compliance with data protection laws, such as the General Data Protection Regulation, GDPR, in the European Union. For example, GDPR's right to be forgotten poses a challenge for blockchain's immutability, as it requires that personal data be deletable upon request. To address this, developers are exploring techniques such as off-chain storage and zero-knowledge proofs to balance data immutability with regulatory requirements. Do you think blockchain-based identity management will become the global standard, or are there challenges that need to be addressed? Share your thoughts in the comments. Like, subscribe, and hit the notification bell to stay updated on the latest trends in blockchain, cybersecurity, and digital identity.